They say we should have known better than to fall so deep down into this rabbit hole.
Get
we found.
ready. It's time again to venture down the rabbit hole into the world of cybersecurity. You're plugged into the podcast for security leaders and practitioners with a business sense. Prepare for unique interviews, insights, and practical advice that makes your job just a bit easier. And now, please welcome your guides on this adventure, James Jardine and the White Rabbit, Rafal Loose.
All right, good morning, good afternoon, and good evening. Welcome down the security rabbit hole to yet another edition of the Down the Security Rabbit Hole podcast. This is Raf. As we careen towards the holiday season here, we're having a great time. We're posting a lot of the video that we record for you guys to check out. We're posting tons of audio content, and we invite you to join us on LinkedIn. A lot of you guys have already gotten invites to that, and obviously, keep the feedback coming. Let us know how we're doing. Let us know if you're enjoying the content, if you want to hear something that we haven't covered yet. But again, kind of as we get into the holiday season, I want to keep it a little bit light, but still kind of talk about some pretty important topics, I think. This one, I've got a fantastic guest. I will let him introduce himself because I absolutely am going to kill his name like people do to me. So I know what that's like. And I know absolutely what that's like. So go ahead, introduce yourself. Give people a little background on who you are.
Hey, good morning, good afternoon, and good evening, everyone. So I'm Kontsevoy. I'm CEO and co-founder of a company called Teleport.
All right. See, that I would have. Yeah, I have an Eastern European background, so I should be able to pronounce Slavic sounding names pretty easily. But I'm always afraid of getting it wrong. So, all right. Thanks for joining us. I've heard of Teleport. I'm glad to have you aboard. But the topic we're going to cover today, which I think you guys are going to appreciate if you're listening to this, is somewhere. Let me dial this back. When I on LinkedIn or Twitter every once in a while get into a rant about how we overdo security a little bit. We get into way too much complexity in security, and we sacrifice usability. This is what that episode is about. So here we are talking with Ev about the intersection of being secure and being productive. So what a great place to start.
Absolutely. So, there's always this trade-off, security and productivity. It's really easy to have easy access to everything, but then it's not going to be secure, and vice versa. If you make everything absolutely locked down and really, really hard to reach and hack into, then you're making it nearly impossible to use.
Well, you made before we went on there, you made a great analogy, talking about the way that this sort of works, and that is, I've got many rooms in my house, and I could make my house a lot more secure than I do now from a physical perspective. I could put key locks or keypads on every single door, to my kids' rooms, to my bedroom, to the bathroom, to the closet, rooms within rooms within rooms, from passage from one room to another. But you know what? That becomes a pain in the right? Like it's not usable. That house becomes extremely difficult to be in, and I feel like IT has done this. We've discussed this from the password complexity perspective because I've had an experience with some friends recently that work in companies where the passwords are like 75 characters long. They rotate every 2.5 hours, and you have 9 of them, and it's specifically designed not to allow password managers and just ridiculous things like that. And I feel like we've lost sight of, not universally, but we have lost sight of, as an industry, the reason security exists, right? And it's to lower the risk, not drive it to zero, but also to make sure the systems are friggin' usable, right? I mean, give me your thoughts. I'm sure you've got some.
I'm not sure we lost sight. I think we as an industry, we actually tend to be very good at maintaining backwards compatibility, right? So your Mac and your terminal you're using your terminal is basically pretending to be a printer. So it's very much the same protocol. So we are firmly rooted in our past. And this is where it's all coming from. Because even before internet, when you had your was like a mainframe or even something like older, like one of those supercomputers, like one of these like old Unix machines, like we had all of our computing done locally.
Yeah.
So which means that if you needed to have access to your data, access meant physical access. If you're in the same room with your data, then you have access. If you're not, then you don't. So which means that we as a security, like as a compute, in the computing world, we would rely on physical security, right? So if you're not allowed to be in a data processing room, then you don't have access to data. So we didn't have to build this technology. It just wasn't even there. But then we started to add networking, right? So the early networked machines, again, it was before the internet, but you now had machines with people in different rooms, maybe even different buildings, having access to at the same time. So then we introduced the idea of accounts, right? So the operating systems at the time, they added this capability for multiple users to have this kind of virtual environments that they're in. So take Unix, take latest versions of Windows, they all have the idea that you have to log in. But then once you're in, then you have access to everything because it's all yours. Again, it's still local. So we introduced just one concept of a password, of a login, of a user identity into a single machine, and then we solved the security problem again. But the interesting thing what happened is that once we went into data centers and once we started to perform computations not on a single machine, on fleets of servers scattered all over the world, so all of that now just no longer works. So we just need to invent something, just like we did back with operating system logins, but we need to introduce same concept right now into the cloud computing world. So we're just a little bit behind. That's what I think is happening.
Well, and I think, to be fair, a lot of organizations weren't necessarily prepared for this because they were stair-stepping their way into that kind of realm. What nobody was really prepared for was this global pandemic that sent everybody home, right? Which means suddenly systems that you could sort of say, okay, only people in the office sitting on this IP subnet can get to these critical systems. Now they're at home.
Yeah. I have an interesting kind of framework to think about, so kind of how pandemic made it even harder. So first of all, let's kind of step back and ask ourselves, like, what does it mean to have access to a computing system, right? So you have you're a company that builds software. You have certain application, a web, cloud native application running in an environment, maybe on Amazon, maybe on Azure, maybe on Google, whatever. So what does it mean to have access to it if you're an engineer? I would say there are probably 4 components that go into it. Actually 3. Okay, maybe 4. So the first one is connectivity, right? How you are going to deliver a packet of data or a command from your keyboard or from where you are, from a client, into that destination. So being able to physically transmit data is part of access, right? So that's one. So for example, if you're in different networks and there are no ports open, there's a firewall between you, so you have no access. So having physical connectivity is one component. The second one is authentication. Like you need to be able to log in into that thing, right? And login means you have to prove who you claim you are. But then there is another one called authorization. Authorization is what actions are you allowed to perform? The access that you're getting, is it a read-only or is it read-write, right? Are you allowed to import export data? So that's authorization. And finally, I think it's really important is to have a full audit of what happened. So once you have all 4, then it means you implemented access into something. Okay, so with this background, if we put it aside, and then we ask ourselves, so what is happening in our computing environments? So what I would argue that they're composed of these layers of technology of variable age. And usually like the lower the level, the older it is. So at the very bottom, you have physical servers. Right? You actually have machines. Then you have VMs. Then you have an API to orchestrate those VMs, create machine, delete machine, provision, deprovision. So then you have containers, because we now like containers as an industry. So containers come from something called Docker registry.
Yeah.
Then you have an API to orchestrate containers like Kubernetes, right? So then you have several databases, because we now use multiple databases for every application. You have MongoDB, you have MySQL, Elasticsearch. Then you have maybe some Redis stuff. Then you have web UI for these databases, or for some of them. Then you have Jenkins, or maybe you have some Grafana dashboards. And I can go on and on and on. All of these layers, they have to exist there already, even before your application gets deployed. And now, for each of those layers, consider this. And there's like dozens of them. Dozens. I can keep going, by the way, in my example. So every layer listens on a network socket. So it needs encryption, it needs user authentication, it needs authorization, like role-based access control. It has its own audit, it has its own config file, written in its own custom language for configuration.
Of course, because
so most organizations now, as they scale, which means that they add more and more hardware, and they also add more and more software into these environments, they're just losing the capability to configure those four things for secure access for every little thing. It's just this scaling pressure that causes this pain. Because again, if you had a single machine, and if your tech stack was like 2 layers, and you had like 5 engineers or 2 engineers, it's not really that big of a deal. You could probably rely on old technologies. So it's this scaling pressure that's really causing everything to break. And now if we're zooming into what happens when you scale, so you get more hardware, then you get more software, but you also get more peopleware. I love examining technology through those hardware, software, peopleware lens. And when your people now are working from home, they borrowing their partners' iPads to run production deployments. That is this kind of final push. Yep, exactly. So that is the final push towards us realizing that we need to have a single login. Let's just call it that, single login. At Teleport, we call it access plane. You need a single access plane to your entire computing infrastructure. Kind of similarly how back in the day, we with the multi-user computers, we invented operating systems with logins. So we now have exact same thing for our entire computing environments.
So that's different. I've not heard that before. So you're saying not just different, more secure access, but singular access that then delegates, or how are you seeing that model? Is it like I log into a virtual console and that virtual console delegates what I can do?
Well, look, I'm seeing it very clearly. Right, we're an open source company that's building it, and it's already in production at many organizations, from NASDAQ to DoorDash and so on and so forth. I'm just inviting everyone to dream. Consider the terminal. Like I assume you have a Mac, or if you have a Linux desktop, that's also cool. All right, so you're launching a terminal. What are you looking at? The terminal drops you into something called a session. How does that happen? Like, terminal knows who you are. It's right there in the prompt. Like in your shell, is it bash or whatever it is you use? Like your username is there. So there, like, you already have a home directory. So there is context for creating that session. Where all of this is coming from? Well, it's coming from you logging into your machine when you turn it on. So right now, notice how our computers are behaving. They're behaving local first. They inherit your, like the session that you're creating, it's a local session, and it inherits your identity. It knows what your home directory is. All of it was like neatly engineered. And then you're launching applications, and all applications on your desktop, they know who you are because they all exist in the same context. But we don't have that for cloud computing. So now if I were to invite you, it's like, what would a remote first terminal look like? You launch a terminal, what do you see? Like, what is it you're looking at? Who are you? Like right now, what we have to do, we have to deal with each protocol separately. So if you want to launch like some people would say, well, Ev, AWS CLI is your cloud terminal, right? You can install AWS CLI package. I think it's written in Python, and you could create AWS config file. Okay, sure. You could do that. You could create your configuration that describes that you're Raf and you have your account on Amazon and your default region is EC2, like East or something, right? That will be true for AWS API only.
Only,
But then inside of that AWS account, you have, let's say, a MongoDB database. And that thing has its own login. It has its own user management. It has its own audit. So then you need to create another config. You need to create another file with another set of credentials to access that database. But then you have SSH machines somewhere. You see, I can keep going and going and going.
Yeah,
it's almost like we have to configure access for. If you imagine that a cloud environment is one giant computer, like your personal matrix, right? It's like you have to configure access for every little part of that computer. And we think there is a huge room for improvement. That's what we're working on at Teleport. Like in Teleport, we effectively combining all of your computing resources into one destination. And then when you launch your session, you're logged into everything you need to be logged in. So we're trying to recreate that experience that always existed for local computing, but we're trying to bring it into the cloud. And it has fantastic security and compliance benefits simply because now finally you have connectivity, authentication, authorization, audit for all of your protocols in one place.
Well, yeah, and you're decreasing the complexity and the opportunity to screw something up, right? To misconfigure, to the typical that's been the problem though. Yeah, I think about IT from going all the way back in sort of your history example. I started on terminals that were connected over serial to a green screen, right, a long time ago in a kingdom far, far away, and it was pretty easy, right? Username, password. Sometimes those weren't even required because as long as you were on that terminal, you kind of assumed you had access and you were supposed to have access. And we got mainframes involved, and we got Novell and Unix and Windows, and you're right. It is frustrating how. I mean, one, it's fantastic to have all that local, like you say, local first, all that access to your local system goes with you wherever you go. It knows where you are. Or as long as I take my MacBook with me. I've always got my playlist. I've always got my my contacts, my email, my files, all that. But I think the world has gotten to a complexity level right now where maintaining that on a small scale is extremely difficult. You start getting into the wider scale, and we get the answer. The previous answers were things like account federation. There's tools out there that you log into, and then you federate credentials into other systems. But I feel like that's just a credential part that does some logging, and
that's a duct tape. It doesn't. Yeah.
It is. It really kind of it's an in between step, right? It's not the solution because ultimately those faraway systems don't really know much about you. Don't have that local context. Because it's
context
all
is the
pushed.
keyword.
Yeah.
I'm assuming your audience is fairly technical, so let me kind of share like what we've seen, what people do for access. The interesting thing is pretty much every tech company, they build their own homegrown access solution. Well, larger than certain size. So you go into I don't know, from like all the FANG companies or companies that are kind of approaching going public stage. Like they all have their own system, how they run like Bastion hosts or access proxies and SSO, and usually it's a combination of open source and proprietary tools kind of stitched together. And the way we see to resolve this this mess of complex components is to agree on a certain architecture. Again, you can build your own access system if you kind of follow this architectural advice that I'm about to get. So first of all, you have to, just to kind of step back, like what are the 3 common things companies do today to deal with access issues? Number 1 is that they rely on shared credentials a lot. Shared credential is when you have like a user called admin on every Linux host, for example, and there is admin.pem, like an SSH key that is stored in some kind of encrypted vault. So that's really, really popular way to kind of simplify access. So over-reliance on shared credentials is one. The second one is over-reliance on perimeter security. So which basically means that you have your VPC, you have your local network, and you have some network policy that opens certain ports into certain places. But once you are inside the network, then things are suddenly much, much, much more open. So that's the second. And the third one is good old bureaucracy, where companies would basically say, no, like you're not allowed to do this, you're not allowed to do this, like ever, ever, ever. But if you need to fill out like a paper form or send a request, and there will be like a person who will approve, and they will temporarily provision access for you. So those are kind of 3 things that are really, really, really common. So here's how you could do better. First of all, you need to say that password-based auth needs to go away. We actually have a fantastic technology that gives us everything we need to create this context. Remember, context is important. Context means that there is something on the wire as part of a protocol, like a metadata that describes who you are, what is your role, what are you trying to do, and then the resource that you're accessing could use that metadata to make decisions on granting or not granting you access. And that technology is called certificates. We have certificates for pretty much most protocols we use. So for HTTP, obviously there is X509, but SSH protocol also has its own certificate. So the way Teleport works, for example, is basically a certificate authority that you have to set up. Then you configure your CA to interact with the source of identities of all of your users. It could be Active Directory, it could be Google Apps, it could be even GitHub, anything that basically has a list of users and their roles. And then when a person shows up for work or says, okay, like it's morning for me, I need to be doing something with infrastructure, the CA needs to issue certificates for all protocols and all resources for that user. And these certificates, they need to be sent to the client, and client needs to be configured with those certificates for everything you need. So that gives you, it actually sounds fairly simple, but it gives you numerous advantages. First of all, because you're using certificates for everything, it means that if you are an intern or if you're an engineer, that's always on the wire. It's part of a certificate metadata. So if you're an intern for SSH, it means you also intern in Kubernetes, you're intern in MongoDB, you're intern in MySQL. Your role within the company is the same across everything you're accessing. It also means that if your access was granted for an hour, and certificates, as we all know, they have expiration date, right? So which means that after 1 hour, you will lose access to all of these things, to SSH, to Kubernetes, to Mongo, to MySQL, to Jenkins. So it allows you to synchronize your authentication and your authorization across the entire infrastructure. So you don't have to rotate keys anymore.
Yeah, let me interrupt just for 1 second, because you hit something that's a big pet peeve of mine, and that is we're really good in the enterprise. Okay, maybe really good is a bad word of saying it. We're good at provisioning access. Usually it's additive. I start off as a desktop admin, then I need access to this, and they add that on. They need access to this, and they add that on, and they add that on, and they add that on. We never really take away access, right? Things never really expire because nobody's got time to review 500 employees worth of 700 systems and 2,000 storage folders and SharePoint and Teams and Google and Microsoft and blah, blah, like all these different places. So if you're telling me you're going to solve that off the bat and you've got a method for solving that, thank you, because that expiration, that ability to do sort of a universal wipeout, like at the end of the day, you're done. You're out. Like, that's it. And you have to come back in with some verifiable credential. I'm assuming 2-factor auth or some other version of strong authentication.
Yeah, biometric.
Gets you into that door. Yep, gets you in that door. And then all that that makes a ton of sense. I mean, okay, so why hasn't this been done before? Like, I feel like this isn't really rocket surgery. Like, this is something we should have just figured out.
So as I said, most sophisticated organizations, they build something similar internally. So look, I don't want to give any examples or disclose how like well-known companies do secure access internally, but go talk to engineers who work at technically sophisticated tech companies, and yes, they build internally something really, really similar. We certainly have in our past lives. So that's one component, and the second one is usually an innovation. It needs kind of few variables to kind of fall into place. On the one hand, there needs to be a need. So the pain needs to elevate to a certain point where people start looking for solutions. For a very long time, even in the early days of the internet, people would just like have some keys sprinkled all over servers, and it was good enough. It was not that painful. So that certainly has happened. Like, we now are in so much access pain that it finally is the right time to build a solution like Teleport. But also you have to be standing on shoulders of giants. You have to have other things evolve to enable to do what you're doing. Notice that when I was describing how Teleport works, in the beginning I said that the certificate authority that issues certificates is connected to your identity. We didn't have identity managers for a really long time.
Yeah, that's true.
It wasn't really possible, like let's say in the 90s or even like early 2000s, for like to create a piece of software that gives you a certificate for any protocol based on who you are. How would it know who you are? Where would it get it from? So the adoption of companies of identity management platforms and SSO happened relatively recently. And that, I think, was kind of final enabling technology for Teleport to start. That's really why we started working on this project in 2015, where it finally became a thing that engineers, they have some kind of access to some kind of SSO system that we could build Teleport on top of. Because before that, it wasn't really happening. Like, even in the open source version, and Teleport is open source, by the way. So if you think like, what is the easiest way for me like to have like few of my buddies, and we're gonna have like a DigitalOcean or AWS account, and we're gonna start hacking on things together. Well, you all have GitHub, so you can connect Teleport to GitHub, and based on your kind of roles, so based on your team in GitHub, like Teleport will issue your certificates for SSH, for Kubernetes, for whatever it is you need to access. But again, GitHub had to exist, right? Like, we didn't really have a thing that every developer has this identity that is like easily available on the internet. Like, GitHub is not that old. So that's another kind of example of why you have to have a certain kind of pre-existing conditions for technology like Teleport to be born.
Yeah, I think there's a lot to be said for at least addressing the complexity of access, because whether it's Bastion hosts jump boxes, I know a friend of mine that works at a company that there are he's a developer. He manages development tools, so he's got like 7 or 8 environments he connects through, and he connects from his workstation to a terminal, right, a remote terminal over SSH. And then jumps from that terminal after he's authenticated via certificate through a firewall segment into another series of systems, and then to go do something else. He closes that session, does another one to someplace else, and it's painful because you in order to keep the systems separated, right, and so you can't bridge them. You can't have sessions into multiple environments at the same time. You have to terminate one, log in the other one, terminate that one, log into this one, terminate that one, log into this one. So if you're copying, pasting code config from one to the other, it is a nightmare of all nightmares. He's like, but this is the way it has to be, because security, because he's not a security guy. He's like, the security team tells me this is the only way to make it secure. And I've thought for years, because this is now an old problem, that there's got to be a better way than that, because there has to be a better way without diluting the security value we put on top of it, right? Because I totally understand the security value that approach brings. I also totally understand why developers want to go murder security people that do this kind of thing.
Absolutely. It's kind of strange, right? That we don't have technology. Well, now we have with teleport, but we couldn't just say, switch me from production environment to staging environment. It was just not possible. At my couple jobs before, we actually had this brilliant idea that we wanted to have production and staging environment to be absolutely identical. And we even had a piece of automation that would name machines in a certain way. Like our databases, they were always like planets, like Luna, Mars, and so on and so forth. So effectively, we had let's just use one example. We had Luna machine on production, and we had like Luna on staging. It would be really easy to confuse the two, right? Like just imagine, you can get into a staging machine or production machine thinking that it was staging. So we had to do like tricks, like we would color the bash prompt in different colors. Like staging would be yellow or green, and production would be red. So you know that you're looking at a production machine. So the fact that we don't have an easy technology that says switch me to staging or production, and it switches everything. It switches your AWS credentials, it switches your Kubernetes credentials, your SSH, your everything, maybe even your DNS. We just never really built it, and now is the time, and Teleport is the product. But I also want to make a second point, because we do need to address the elephant in the room, that there are plenty of people out there who correctly say that maybe we shouldn't be manually touching every single thing, especially in production, right?
That's fair
so
enough.
It kind of rolls up into the serverless movement. I would say that the best experience for a developer is to fix a bug or implement a feature, create a pull request, push it into Git, and go home. That's it. Your job is done. You shouldn't be tinkering with all these individual components. And that's the future that I hopefully we will get into. But unfortunately, we're not there yet. And unfortunately, the state of software development is that we still need to touch a lot of things individually. Maybe it's not servers, maybe SSHing into machines is not really that popular anymore. But look, we deploy a lot of things internally. Now people are tinkering with Kubernetes, right? So then they have, web apps deployed internally, like Grafana and numerous others. And the same problem kind of continues to exist, again, because complexity is not going away. So that problem truly doesn't really go away.
You know, the complexity is a particular pain point of mine, because I feel like when I was learning computers, it was, we thought, boy, this is a really complex system. I could I can Control Shift Escape on my Windows laptop or system, and I saw all the processes that were running. I could pretty much knew what all of them did, through NT, through Windows 95, and through most of the platforms. And we got into like. By the time Vista came around, I looked at them and went, I don't know what half of these do, or why are there so many? And now you do Control Shift Escape on a Windows 10 or Windows 11 machine, you're like,
I lost hope.
This is no idea. I mean, that's awesome because we've now microserviced within the operating system, right? So this thing only does this task, and this thing only does this task, and that's great for security, potentially. But complexity always wins out, and complexity doesn't cause good things. And you're right. Like this, the access problem has been traditionally difficult to solve, because for a lot of the environments, it's just-in-time access, meaning I only need this access once, but I need it right now, and we don't have time to configure it. So just give me God access to this system. I'll log out when I'm done. Sure, right?
But also, what would be interesting? You and I, we've been kind of talking about this problem from a user perspective, from an engineer. Like, engineer needs to get into Kubernetes. Engineer needs to see, like, why is, like, I don't know, like, disk latency is really, really high on certain infrastructure. But, like, consider yourself being responsible for security at your organization. Like, there are people, too. Like, they have the responsibilities and jobs, and it's actually it's kind of scary role to have, right? To be responsible for your company never getting hacked into or losing data. Okay, so then I have a question for you. Like, can you tell me, like enumerate all live connections that exist right now into your production? Like, who is doing what? Do you really have that view? For example, what if I said, hey, Kontsevoy has gone crazy or has like just acting strangely, like we need to cut his access. Like, do you really have a thing? Do you click a button and Kontsevoy is like disconnected? Maybe because, I don't know, like I got bribed by your competitor to steal your data. Like we just had this in the news just recently, right? There was the name of that company escapes me. So do you have the capability to exclude a certain person in real time completely from production today? And you'd be surprised how many organizations just know, like we don't.
I think most would say have absolutely no idea.
Yeah, like because if you're using shared credentials, that's it. Like that, it means that person has exact same credentials that they borrowed from Vault of some kind that the rest of your team. In fact, cutting access, like you made this interesting comment earlier that access is usually additive thing. Very rarely we take it back. You know why we don't do that? Well, when I say we, I mean the industry. It's because there is a real risk of you going down hard, because you might discover that this credential that you're pulling out is used by a piece of automation that someone just copy pasted that key into Jenkins or whatever, and now your production pipeline actually depends on it. So you kill it, and then like your deployment fails, whatever. So that's the kind of problem that security people are dealing with, that they're unable to see all the live connections that go into their infrastructure. They are unable to cut access in real time. Even if, for example, let's just say one of your engineers just gets promoted into a different team, and that different team has different rules, different policies. So are these policies going to be enforced in real time now, right? Another example is, like, if you are accessing, let's just use SSH. Like if you're accessing like a bunch of SSH machines, is there like a place to see what you've done? Because SSH logs usually just say, hey, user, like, admin logged into a certain box. Yeah. But can you tell me if is that person uploading, downloading some data, creating, deleting files? Like, is it even visible? Can you tell what is really going on? No, we don't. This is why I like this analogy to local computer. If we start treating our cloud environments as a single machine, it means that there's a single log that shows you what is going on. So that's really what we are building with Teleport. So in Teleport, if you're creating a session into a cloud. And then everything that happens within that session, we can tell. We could say that, hey, Raf downloaded some code from GitHub and running it right now. And that code is now creating, deleting files, uploading, downloading something. So you have full visibility into what is actually happening. Like, what are you doing with that connection across the entire fleet? I think it's really, really important capability that by unifying all of it in one place, we finally, hopefully, will get into this kind of simple state of access.
The amount of the amount of detection that you can do of and granular detection of badness that you can do, let's make it. Why bad? The amount of detection that you can do of oops detection that you can do, right? The person logging into the wrong production versus staging, issuing a refresh command. Suddenly production goes down or something's going on. And you can set triggers in some logging platform because you're logging this or something, I imagine. It's hey, if this happens, like, let us know because we need to go undo that. Because maybe it was hopefully it was an accident, but maybe not.
But switching back to the user perspective, I would even say that this is an interesting capability to be able to see what you're doing, even for your own curiosity's sake. You know how some open source projects, they have this installation instructions that you curl something from the URL directly piping it into Bash, and the installer runs and something gets installed? Well, normally, if you you would get into a box via SSH and you're gonna run that thing on a remote server, you kind of don't really know what happened, and there is no audit for you to even understand what this thing just did. But if you're using Teleport, we will actually tell you, user Raf logged into this machine, and he executed curl, and then he executed bash, and then bash downloaded this file, and then this file launched Python, and then Python started to download another payload. So we basically will tell you all the system calls that are happening when you're running that script, and it's basically a tree of this. It's kind of similar to like a profiler, if you ever use interactive profiler.
Yeah.
And it's kind of interesting. So you're running the script, and you will see exactly what this thing did. Oh, it created a bunch of files. It deleted. It created some temporary stuff, deleted, and then it gives you a peace of mind that I did not do anything crazy. So even as a user, like, there are benefits in having a nice access system that is comprehensive.
All right. Well, we've run out of time. In fact, we probably should cut it off because we could keep talking about this, I think, forever. But Ev, thanks for giving us some insight. I appreciate it. And boy, my mind is running all over the place with ideas on what we can achieve through this. I will definitely post a link to Teleport, so for folks that want to go check it out, because that is an interesting platform for sure. And boy, it's interesting to talk about productivity, especially during the holiday season, during what coming out of, I hope, one of the worst pandemics that we've seen in our lifetime, and that's, I'm not convinced it's all over yet. With the different access requirements, the different systems, the complexity of what you're doing, where you're doing it, who's doing it, and all that, going up and up and up. This is good. It's good information to have, to sort of dream the big dream of, if we could rebuild this whole thing, what would it look like? So thanks for joining me. This has been fun.
Likewise. Thanks for having me.
All right, folks, thank you for listening to yet another Down the Security Rabbit Hole podcast episode. As like I said, getting into the holiday season, I know some of you guys are taking some time off or maybe going back through back episodes. There is some good stuff in the back of the catalog. Episode 100 is one of my all-time favorites, and I'll keep posting Throwback Thursday stuff as we go. But we're going to go right through the holidays and go check out the LinkedIn page. We've got a Twitter feed, DtSR_podcast, if you don't know that one. Hopefully you've subscribed to the RSS feed, which is how you're listening to this. But now officially we're on Spotify and iTunes and all the other places you get your podcasts. And by the way, if you don't know this yet, Grant, Gary, and I started a show called The Above Board Show. It is a weekly Tuesday. I'd love to have you on that someday, talk about enterprise problems. But it's a 15-minute format live on Tuesdays at noon Eastern. It's on LinkedIn. You'll have to go find that. But we kind of address board level security problems in conversations. So hope to have you guys there. Thanks for listening. We'll catch you guys another time, another place, on yet another Down the Security Rabbit Hole podcast. Take care, everybody.
As we fade out on another Down the Security Rabbit Hole episode, we'd like to encourage you to chat with our hosts and guests using the Twitter hashtag #DtSR. Please check out the show notes, catch up on any episodes you may have missed, and subscribe so you don't miss a future episode. So on behalf of Rafal, James, for now it's goodbye. We'll see you soon on another Down the Security Rabbit Hole podcast.